Good morning. My name is Aihara from University of Tokyo. I am serving as the Executive Vice President in charge of quantum mechanics. I have a sore throat, so my voice is not so perfect. I hope you will bear with me. So I would like to introduce to you our university's quantum initiative. Hardware, software development is at the heart. And we are really positioning this as a very strategic research area. And specifically, number one, the strategy is that the collaboration across the academia industry and the private sector, the creation of the quantum test bed. And another is that supercomputer technology research as well as a quantum technology, putting them together, hybrid in a fashion, fault-tolerant quantum computing is therefore what we're trying to realize. So we are having research and use case research for the sake of fault-tolerant quantum computing, and also promotion of the development of quantum talent and the enhancement of the computational infrastructure. So these are the strategies that we have been focusing on. And the next slide is very busy. At the university, I have tried to pack everything that we have done at the university so far. I'd like to start from the top left. Starting from optical quantum computers, hardware development for the superconducting quantum computers, and also theoretical studies in the quantum sensors, among others. And the middle part, in 2019, December, Japan IBM counterpart partnership was announced, and in Kawasaki City, we have this IBM system, Quantum System 1, that is leveraged for research of quantum computing, including the social implementation. We are promoting the commercialization. And in Kawasaki system, 127 qubit processor is in place, and moreover, we are going to upgrade that further to a higher level of quantum computing system. And in the Hongo campus, University IBM testbed center is there for miniaturization, and also having this superconducting cables, among others. And we are collaborating with Japanese domestic companies so that we're supporting the private sector to go into the area of quantum computing. So this quantum hardware center is for scaling up of quantum computing. This is one of such a test bed that we are offering. And so that is really in the middle portion, in the middle band. So quantum computing is to be commercialized or implemented in society ahead of other countries, and therefore we are promoting academia, private sector, public sector collaboration, so that overall Japan can enhance its level in quantum computing, so that we can implement quantum computing in society. And the Quantum Innovation Initiative, QII, was established. And 22 organizations, including the academia, are participating. Financial companies, chemistry companies, information technology, energy companies, among others, very diverse participants. And this is really the only hub that really serves both the private and the public sector in their collaboration. And if you can take a look at the left bottom portion, we have this collaboration with Chicago University, RIKEN, and the quantum sensing algorithm, as well as communication, are the areas where we establish platforms to promote these areas of research. And IBM, Google, and other universities, we have innovation education provided involving other partner universities and institutes. We're developing human resources that can develop the research, but the technologies as well as those who can apply the technologies. And on an annual basis, there are about 300 people that go through our educational programs. And this is the third slide. Again, this is a little busy as well. At the university, these are the strategic themes that we addressed in the past 5 years. Top box on the left, I would like to explain that first. So the first strategy is the quantum-centric supercomputing QCSC being promoted. And the IBM system facility in Shinkawasaki, and the Miyabi, which is the post-Fugaku computer, we're using both to have hybrid computation. IBM System 1 in Shinkawasaki right now has 127 qubits, but in September this year, it is to be upgraded further. On the other hand, Miyabi uses GPU and CPU, an integrated fashion. It's a super chip. NVIDIA's GHG200 is used, and AI-capable supercomputer is what it is. And the bottom left shows that there is this capability that can make machine learning possible with Miyabi, and we can actually predict, make predictions, and AI computing being more advanced is what we are researching on. And also the optimization is being pursued using Miyabi so that we can develop further algorithms. And with the application development, we can actually conduct functional simulations so that material science can be enhanced, and traveling salesman problem being one example. We can actually promote or pursue the optimization problem solving. So these are some of the use cases that we believe can be implemented in society to solve the social issues that we have. Last year, IBM and other countries have actually announced that they will have this fault-tolerant computers in this decade, and therefore I think we are entering a new era. And we have collaborations with Chicago University, among others, and the algorithm development for the age of fault-tolerant quantum computing, and also the further technological development that are beyond that phase is in our view as well. And the last box on the bottom right shows scientific innovation through quantum technologies. We are pursuing that as well. For this area, basic scientific research is what many students are interested in, and this is really stimulating to these students. And super precise physics experiments, as well as the particle science related research is something that can win a Nobel Prize in the future, possibly. So these are some of the areas that we are focused on. So it's a really summary, but so the use case implementation is at the very highest priority for our university, and we want to become the flywheel for accelerating quantum research and growing a quantum ecosystem. We believe that we can do this, and with the collaboration across the different sectors, we will try to make Japan a country based on quantum computing technology. I apologize for a rush in my explanation, but thank you very much for your attention.